Hey guys. Okay, so since I'm not there, I just wanted to run you through a couple of things. This first part is for the worksheet that you're doing. I just wanted to remind you how we were finding the height of Carlos. So remember, this part is the height. We know that this part right here, that is the radius of the Ferris wheel, and we know that the center of the Ferris wheel is 30 feet off the ground. So we have all of this information. So if we zoom in on this triangle right here, boom, zoomed in. Then let's see what we have to work with. Here is the angle. We have this side over here, which is, anybody? That's right. That is the opposite side of the triangle. And then we have this side of the triangle up here, which is, anyone? You are correct. That is the hypotenuse of the triangle. So which one of our trigonometric ratios is opposite over hypotenuse? If you are sitting there saying to yourself, I'm pretty sure that's sine, you are correct. So the sine of the angle, which is 30 degrees, is equal to the opposite, which is x, over the hypotenuse, which is 25. And then to get the x value, which is what we're trying to get right now, I need to move this 25 over. And how should I move the 25 over? We're going to multiply by 25 on both sides. And then I get 25 times the sine of 30 degrees equals x. Okay, so as a recap, this part is the radius, this part is the angle. Now, what about the height? How do I figure out what the height is? Whoa, that's not what I meant to do. That was crazy. Did you see that? That was crazy. Let's zoom back out. So the height of the Ferris wheel, remember, is 30 feet. So we know that this x value right here is 25 times the sine of 30. That's this part right here, equals 25 times the sine of 30 degrees. But then we also have to take into account this part right here, which we know is 30 feet. So our total height is going to be 25 times the sine of 30 degrees plus 30 feet. So that's the total height. I'm going to use like a y equals for that so we know it's an equation. Okay? Okay, so let's go look at some more of this equation business for the next couple of questions. Here we go. Okay, so we said on the last slide that our total height is going to be y equals 25 times the sine of 30 degrees plus 30 for our height. So just what I want to point out to you is this is the radius of the Ferris wheel. This is the angle of like where, like how far Carlos has moved around the circle. So maybe he's there, or maybe he's like way over here, or maybe he is all the way, like he's gone all the way around. So whatever that angle is, that goes right there. And then the last part is the height, I'm going to say of the center of the Ferris wheel. Sorry, my handwriting is atrocious on here. So the height at the center is like, if this is the ground, like how far up off the ground is the Ferris wheel? Because we want to, if Carlos is sitting right here, we can find this height, right? But then we also need to add in this height right here. So we have to add that. So that's the height of the center. So I just want to make sure you know all of those parts. That's going to help you as you answer the next few questions. So if you change the triangle, how does that change the equation? So for example, if you had a Ferris wheel that had a 50-foot radius, because it's, excuse me, it's gianter, and then maybe Carlos was sitting at like 42 degrees up. Here's his little car right here, and he's all like, Hey, guys. Remember he's waving. Hey, guys. He's so scared. Um, um, sorry, it's trying. Okay. Okay, hi, Carlos. Um, and then let's say this is part of a Ferris wheel that is, that was a terrible circle. We're going to do that again. Let's say this is part of a Ferris wheel, and the Ferris wheel is, I don't know, we'll say 25 feet off. No, let's not say 25 feet. Let's say 22 feet off the ground. So how does that change the equation? So remember, on the last slide, I told you what all the pieces of the equation were. So we're still using sine because we're trying to find this part right here. We're trying to find the x. So sine is the opposite over hypotenuse. So that means opposite over hypotenuse. That's this guy right here, opposite, and this guy right here. That's the hypotenuse. So I'm going to say the sine of 42 degrees equals x over 50. And then I need to get rid of the 50, so I'm going to times both sides by 50. By the way, I'm doing a lot of kind of, I don't know if I'd call it extra work, but I'm just showing a lot of steps. You can just write the equation if you know what the equation is going to be. I'm totally cool with that. Or I think the questions are asking you more how to describe what's going to change. So be very explicit about what's going to change in your equation. Okay, so this, once we get all of this, that is going to tell us the height of the car. So it's going to tell us this part right here. But then, if 42 degrees, that means Carlos is sitting right around here. So that'll tell us this height. But what about all this height right here? That means we need to add that extra height at the bottom. So my total height altogether is going to be 50 times the sine of 42 degrees, and then I'm going to add 22 feet at the end. I'm going to make that y equals to all that. So that's my final super equation. Okay, so pause this, go finish the questions on your worksheet, and then when you are ready to move to module 6.5 in your books, which is after you do the worksheet, come back here. Don't forget, you need to hand your worksheet into the sub so I can take a look at them. Feel free to work together. We learn better when we learn together. But make sure you think about it, guys. Use your brains. Remember, you are good at math. Okay, pause, do your worksheet, then come back. Okay, we're back. Guys, I hope you're at section 6.5 right now. I don't know what page that's on because I don't have my book in front of me and I forgot to look at the page number. But 6.5, go there. I'm going to wait for 2 seconds. So if you need longer than 2 seconds to get there, pause this and get there. 1,000, 2 1,000. Okay, I'm moving on. I hope you're there at this page. Okay, so we're taking that same Ferris wheel, guys. Here's all the good stuff that we need to know about the Ferris wheel. It has a radius of 25 feet. The center is 30 feet above the ground. It makes one complete rotation counterclockwise every 20 seconds. Good stuff. And in the last couple sections, we were talking about Carlos's height. So, how high he was up off the ground. In this part, we're going to talk about something slightly different. I don't know if you guys can hear that in the background. Those are my chickens. They're in the house. It's weird. They're saying hello. They love math. Okay, so what we want to do here, to describe the location of Carlos's shadow as it moves back and forth on the ground beneath him, we can measure the shadow's horizontal distance in feet to the right or left of the point directly beneath the center of the Ferris wheel. Okay, so let's kind of figure out what that's talking about. So if you, let's zoom in on this part right here. If you are standing right here, hi, that's you, and you're like, hey Carlos, you're my buddy, I'm watching your shadow. So right now, Carlos' shadow is going to be way over here, and then as he goes, he continues around the Ferris wheel, then his shadow is going to be over here, and then as he continues around the Ferris wheel, then it's going to be right here, he continues around, it's going to be right there, and then et cetera, all the way around. So the shadow is moving in this side-to-side direction. So we're not talking about the height anymore. we're talking about a side-to-side movement of Carlos instead. So if I'm thinking about this triangle, what do I know about this triangle? I know that this bit is 25 feet. Oh golly, that was a terrible 5. That's a 5. 5 feet. Here's my little triangle here. Voila. And then I can probably figure out what that angle is. So now, instead of the height part, what we're looking for is the horizontal part. So how far to the right or to the left is Carlos's shadow. So now the X is down here. Ooh, So let's, I'm trying to move things and it's not working. Okay, so, whoa. Hope you don't get motion sick, y'all. Okay, so let's go back now that we know what we're actually doing. Let's finish reading. We're going to graph this with locations to the right of the center having positive value and locations to the left of center having negative values, just like a regular coordinate plane. Incredible! For instance, in this system, Carlos' shadow location will have a value of 25 when he is the position farthest to the right, because that's the radius of the Ferris wheel. So when he's all the way over here, he's going to be the maximum distance away, which is 25 feet, way over here. And then a value of negative 25 when he's way over here to the left. So positive 25, negative 25. Okay, so what would Carlos's position be on the Ferris wheel when his shadow is located at 0 in this new measurement system? Well, if it was a 0, so all the positive shadows are up here to the right, all the negative shadows are down here to the left. So 0, I assume, would be right here in the middle, right? Okay, so what we're going to do is we're going to sketch a graph of the horizontal location of Carlos's shadow as a function of time t, where t represents the elapsed time after Carlos passes position A. So remember, position A is right here. I should label it. Let's put a red label right there. A. That was giant. That was too big. I apologize. We all know it's position A. Now we know. We feel better. Whoa, motion sick again. Let's straighten this out. Okay. So we're going to sketch a graph, the farthest right position on the Ferris wheel. So we're going to need some values. We're going to need some numbers. But what we do know is at the very, very, very start, when he is at A, so at 0 time passed, how far is he away? How far is his shadow? Where's his shadow at? When he is sitting right here, his shadow is going to be at the maximum distance, so it's going to be 25 feet away. So I know that I can put a spot right here on 25 feet at 0, because that's how far he is away at 0. Positive, because remember they said positive was to the right, and negative was to the left. So it's going to be a positive 25. Okay, so we know that it takes a whole, what does it say up here? One complete rotation counterclockwise every 20 seconds. Okay, so let's think about that. Counterclockwise means, counterclockwise means we're going this way, right? The opposite of a clock. So if Carlos is going, hopefully not that fast because he would die, if Carlos is going this way, that means at 20 seconds, he's going to be back around to A, right? So 20 seconds, boom, back around to A. So after 10 seconds, which is exactly half that, he's going to be right over here. So where's his shadow going to be? Right back here. It's going to be right below him. So his shadow is going to be, how many feet is this all the way out? That's 25 feet all the way out back that way. So I can go ahead and put in some other stuff. I know that at 10 seconds, he's going to be at negative 25. And then I know at 20 seconds, he's going to be back to positive 25, like that. So I can kind of see what my graph is going to look like. It looks like a V right now, which is weird, but we'll go with it. So, how can I figure all the other stuff in between? Guys, I think it's time to make a table. Let's turn the page. Hey, look, there's a table for us. So, here we go. Let's make a table. I'm going to take up a few blocks of the table here, and I'm going to sketch a diagram of Carlos's position. Right angle. Here's where Carlos is. Hi, Carlos. How's it going? Carlos is having a hard time here. I wish I could draw stick figures better. Carlos is like, let me out. Okay, so we know, remember we said in the last lesson that he moves 18 degrees every second, right? So after 1 second, right here, how many degrees has he moved? 18 degrees. After 2 seconds, how many degrees has he moved? 36 degrees. After, 3 seconds, how many degrees has he moved? Some quick math, 354 degrees? I'm going to stop there, but you can continue that so you can figure out how many degrees has he moved, because we need to know the degrees. Why? Because we need this angle right here. What? Okay, so I'm going to do 1 second and calculate that with you guys. So at 1 second, I know this angle right here is 18 degrees, right? What else do I know about this triangle, this Ferris wheel that Carlos is on? I know that this side, the radius that's holding his little car up, that is 25 feet. What I am trying to find here is this part down here, the horizontal. How far away from the center is he? So this is now my x value. So let's think about this. Here's my angle. I know this side. What is this side right here? Anybody have anybody? I almost wrote opposite. That's not right at all. It's the hypotenuse. What about this side down here? This is what we're trying to find. Anybody know what side that is? You're correct. It is the adjacent side. Adjacent side. I feel like that needs an air horn. Here's a little air horn. That's the worst air horn I've ever drawn. That's okay. Live with it. Okay, so we have the adjacent and the hypotenuse. Y'all, what ratio is adjacent and hypotenuse? It's the cosine. So the cosine of this angle, 18 degrees, is equal to the adjacent, x, over the hypotenuse, 25. How do we get rid of that 25? We multiply both sides times 25. That's a 25. And then we end up with 25 times the cosine of 18. That is equal to x. That is going to tell us how far away from the center, so basically this distance right here, it's going to tell us how far away from the center Carlos is. Y'all, I should have been prepared and had a calculator, but I don't, so just hang tight and talk amongst yourselves while I do some calculations real quick. I wish I had a joke for you. Let's see, what's a good joke? I just heard a joke. What was the joke? Oh, no, it was a terrible joke. What's a good joke? I just heard, it's fine. I know you guys are sitting in the classroom like, what is going on? Okay, good, I just did some math. So I have found that this is equal to 23.78 equals x. So my calculations here that I'm going to write are just going to be, I did 25 times the cosine of 18 degrees, and that is equal to 23.78 feet. So then, what I want you to do is to go back and go back and graph that on the diagram. Y'all, what do you think that this one is going to be right here? Does the radius change? No, the radius is made of iron, so it's going to stay the same. We're still using cosine because we're still looking for the horizontal part of this triangle. It's just that our angle is different, so now it's going to be cosine of 36 degrees. Hint, hint, this is a pattern that continues. So what do you think is going to be here for 54 degrees? that's going to be, I'm going to scoot it over next to Carlos, 25 times the cosine of 54 degrees. What? You are crazy. Okay, that's all you need to do. Fill out all of this table. Graph all of these points. I know you hate graphing, but it's, you know what? It's a joy. Think about it like connecting the dots or coloring. You're centering yourself. Pay attention to accuracy. It'll be great. So do that. And then your homework, y'all, is going to be ready and set from Module 6.5. Ready and set from Module 6.5. Okay. I hope that you're being good for the sub. You better be being good for the sub. But I know you are, because I trust you, and you are talented mathematicians. Y'all, I'll see you on Wednesday. Deuces.